this video we're covering exponential curves. So on your screen you can see a basic exponential curve, y equals 2 to the power of x. So an exponential curve occurs when x is the power of a constant such as like a. In the last example we saw the constant was 2, and this forms a graph known as an exponential curve. So again, when you have some sort of constant such as 2, 4, 6, anything like that, and x is in the power, that forms what we call an exponential curve. Now on your screen you can see two examples of exponential curves. In red you can see y equals 2x, and you can also see its graph. And then in blue you can see y equals 5x. Now it should be noted, and you can observe it by looking at these two graphs, the smaller that a value, the wider I guess it goes, and 5 the steeper it is. So with the blue graph you can see that it's increasing much more quickly than the red. So here are some features of the exponential curves. Y equals a to the power of x. So remember, y-intercept for exponentials is y equals 1. This is for all exponentials unless there is a constant at the end, which we'll go into after this slide. So again, y-intercept for exponentials is y equals 1. So as x increases, as we're going from left to right, y also increases at a faster rate. So that's what gives you that curve going up. They're not increasing at the same. The bigger x gets, the bigger y gets, and more quickly. So as x decreases, y starts to approach 0, but never actually reach it. It just approaches it. Now, the larger the a value, the faster the graph increases. So that's what we covered before with that blue and the red curves. Now another thing to note is that if the a value is negative, the graph decreases. So now you can see on your screen we have 2 to the power of negative x, and this time it's decreasing. It's going from top left to bottom right. So here are some more features of exponential curves, and more so we're actually looking at our c value. So as you can see on your screen here, we have c controls our y-intercept. So if c was -2, the graph moves down 2 positions from 1. Now remember, it's always at 1 this time. So instead of we're just going, oh, c's -2, so it's crossing at -2, it actually just crosses 2 positions down, so this time at -1. Now if c was +2, the graph moves up 2 positions from 1. So in green you can see it's crossing at 3. Here we have some examples that we're going to cover, and you can feel free to pause the video to try and match up what you know, and then I'll go through the answers. So the first one, y equals 2x, I know that's a pretty standard exponential curve, and there's only two roughly standard exponential curves here, number 1 and number 2. Now I know that 2 is a relatively small number, so I would expect it to be increasing, but not as much as the second one on 8. So I know that y equals 2x is matching with graph 1. The next one, y equals 8x, again pretty standard exponential, except 8 is starting to get a relatively big compared to all our other graphs equations here. So I would expect this to be my steepest one, so number 2. Next we're looking at y equals 2 to the power of -x. Now remember, if it's negative, it's decreasing, so from top left to bottom right, and the only graph that has that is number 4. And lastly, we've got 2x plus 1. So we're looking at plus 1 at the end, which means we're moving up 1 position from 1. So 1 plus 1 is 2. So I'm expecting it to cross at 2, which is number 3.